In today's lesson, we're going to be taking a look at more diagrams with similar triangles and proving that they are similar and also figuring out the sides, but maybe a little bit more complex proportions. So in this diagram, we have BE is parallel to CD, so those are parallel, and CD is also perpendicular, meaning forming a right angle with, there's no letter here, so we're going to call it DA. DA is right down here. So those are perpendicular, meaning they form 90-degree angles. So the two triangles we are comparing, the similar triangles we are comparing in this case, are the smaller triangle with the bigger triangle that surrounds it, and I'll color coordinate it. So we'll color coordinate the bigger triangle to be the blue triangle. So we're comparing that with the red triangle, which is the smaller triangle inside of it. Now we have to figure out the angle measures of each of the triangles. So the red triangle, we have 90, remember the box is 90 degrees, and a 28-degree angle. So to figure out the third, we do 180 minus 90 minus 28, which is 62 degrees. So this is 62 degrees. Notice in the blue triangle, they have the same two angles. They have a 90 and they have a 28 also, so this one's also going to be 62 degrees. So they are similar. Because both are 90, 62, 28-degree triangles. All right, now figuring out the sides. So I'm going to make some space. Actually, you can leave those there. Again, I'm comparing the small triangle with the big triangle. We have to see a pair of similar sides that are labeled in the small triangle and the big triangle. So the pair of similar sides, when I'm going to use my proportion, are this side right here, the 5 inches and the 10 inches. Those are the pairs of similar sides of the small triangle and the big triangle. So those are going to be part of my proportion. So remember, when a proportion is an equation with two fractions equal to each other. So the 5, which is of the smaller triangle, and the 10, which is the bigger triangle. In the smaller triangle, we have 3x. Let me do this different color, 3x. And of the blue triangle, the bigger triangle, the side similar to that is this whole base right here. So the side similar to the 3x is the whole base right here, which is 3x plus 12. And again, notice the order of the fraction, what goes on the top and what goes on the bottom is important. We have the red triangle right here. Okay, those sides are on top, and the blue triangle, which is the big one, okay, those sides are on the bottom. And their respective similar pairs are aligned. All right, now, again, to solve a proportion, we cross multiply. Now, this is a little bit different, not as easy as the last lesson. When I cross multiply with the 5 times 3x plus 12, I have to distribute the 5 to the 3x and to the 12. So we have 5 times 3x, which is 15x. And 5 times 12, which is 60. I'm also going to Cross multiply here. 10 times 3x is 30x. Solve. I'm going to minus 15x from both sides. And you get 60 is 15x. Divide both sides by 15. And you get x is 4. Now I'm not done. I just solved for x. I have to find the missing side, so I have to plug it back in. So my answer then is 12. 3 times 4, which is 12. And that makes sense, right? 5 over 10 is 1/2, right? 3 times 3x, we know that's 12. 12 and 12 is 24, right? 12 divided by 24 here also reduces to 1/2. So they are forming a proportion. All right. So again, reiterate the importance of the order of where you put the numbers in the fraction. And also remember, similar triangles are triangles that have the same measure of all the angles, and all the angles add up to 180 degrees. So work through these problems. The toughest part is setting these up. So once you have them set up and solve for x, you should be good from there. All right. But if you have questions on setting them up and making sure the proportions are correct, let me know. Thank you.